うん Mr. Adria,
Hello, can you hear me now?
I can't hear you.
Oh, what's the problem? Oh, hey, Eliana. Hello. Hello. Adwa,
Mr.
can you hear me?
Adria,
Can you hear me? Hello, Adwa.
Mr.
Eliana, can you hear me?
Please, I can
yes,
now hear you.
please.
Eliana, you can hear me now.
Mr. Adria,
Hello, Adwa. Hey, Asamni. Can you hear me?
Mr. Adria,
Adwa, Eliana.
yes, please.
Mr. Adria, please, I can hear
Mr.
you.
Adria,
Okay, if you can hear me, that's fine. How are both of you?
Please, we are fine, thank you. And
Okay.
you?
I'm also fine. Thank you. Okay. Hey, what? Hey, Eliana and Adwa, you are the first two to be around. What I'll do is that you see the questions I gave to you. I sent to the platform.
yes, please.
I will answer it and then send the solution to the platform so that you can use that to correct your mistakes. Okay.
Yes, please.
Because we can make time to go through each one of them, because today we want to even start with moment. Okay. Sanam,
Yes, sir.
good morning.
Good morning.
How are you?
I'm fine, thank you.
Okay, so you are just okay. Who is also Dromo is joining? Let's give ourselves 2-3 minutes for your other colleagues to join. Okay. Kezia too is joining. So let's wait for them. In the meantime, if you have any question, you can ask whilst we wait for your colleagues. Eliana, do you have any question? Adjoa, do you have any question? Kezia, Sanam, Dromo, any question? Any question? No question.
For me, no.
Hey, Adwa, you too.
No, please.
Dromo, Sanam, Kezia. Any question? Hello. The network has started immediately. Hello. Sorry. Hello. Hello.
Mr. Edia.
My network was misbehaving. All right. Let's start. Can you? I hope you can hear me.
Yes, please.
Okay. So as I said, today I want us to look at moments. Moments. Moment. So moment. Ladies, what is moment? If by chance you've read something about moment, what is it? Can you share it with me? Eliana, what is moment? Senam, what is moment? Adwa, Dromo, Kezia, what is moment? Any idea? If you have no idea, let me know so we could go on. Okay. Here I will take silence to be no idea. Moment.
Mr.
Hello. If you are sharing something with us, please hurry up.
Please, I'm trying.
Uh,
Please, is the turning effect of a force.
around a fixed point. Okay.
Yes.
You are right. When we talk about moment is it is the turning effect produced by a force around a fixed point. A fixed point. And this is what you learned in the JHS as a pivot. Pivot or what? Pivot or
Fulcrum.
fulcrum. That is what we mean by movement. So look, I have this. Once I hold one end of it firmly, when I apply a force to the other side, this thing will turn either up or down. If I apply the force down, it will turn. If I apply the force up, it will turn up. So we describe moment as a turning effect produced by a force. Okay. A typical application of moment is that you see your doorknob. If you want to open your door, you hold the doorknob and turn it, okay, in a particular direction. You realize that the doorknob is fixed to the door by something. There is a pivot. So you hold that handle and then you turn, then the key unlocks and you open. That usage of the door knob is a typical application of moment. Another application is that you see the same door. When you are opening, your door is connected to a metallic thing, to the wood, which we call as the hinge. That the hinge is the pivot. So when you hold your door and then you apply a force as in forward, you close the door. If the application of the force comes backwardly, your door turns, okay, backward. You push it upward, forward, it turns inward, okay? So the opening and closing of the door is also an application of moment. Then if you are opening the metallic end of a soft drink, you put the opener in place, then you apply a force on the handle of the opener up. When you do so, you realize there will be a turning effect. The handle will turn up, then it will open. Okay. So opening the top lid of soft drink, hard drink, middle drink, whatever, also applies the concept of movement. Then when you are riding a bicycle, your leg exerts a force on the pedal, okay, both legs. So we also have force acting around a point, okay. Then seesaw, when we were kids, we had this our own seesaw, which is like this, a bar. Then this bar is placed on something. This thing serves as the pivot. So somebody sits here, somebody sits here. I exert a force downward and there will be turning effect. This will turn. Okay. If Adwa is at the other end, Adwa exerts a force this way, and then Adwa turns. Mr. Dio also turns. So that seesaw, which we use a rigid bar to do, is also an example of movement. Please, are you following?
Yes, please.
Yes, please.
Then when you are driving, we have movements taking place, application of movement. You exert a force at one side of the steering wheel, you exert another force at the opposite end. So as you drive, this is what you do, okay? So force acting at a distance from the axis of the steering wheel, okay? It also creates a movement. Adwa, you wanted to say something? If you have a question, quickly ask so we can continue. Any of you? Okay, now, so this is how we define a moment. It is the turning effect produced by a force.
Is there, dear, please? I have no question.
Okay, around a fixed point. How do we calculate moment? Moment is the product of the force and the perpendicular distance. So we determine or we quantify moment by multiplying the force by a perpendicular. This is my short form notation of perpendicular distance. So you realize that moment is almost similar to work. Work is force times distance. The product of the force, but for moment, the distance must be of a certain character. It should have a certain behavior. And the character is that the force, the distance must be perpendicular to the distance. So if you have maybe the force over here, F, then the distance must be in this direction, S, and they should be of a certain character. So either the force is here, distance is here, or distance is here, and the force is also here. So the two must have a particular characteristics. Because of this behavior, we say that moment is a vector quantity. But its similar brother, which is force, is a scalar quantity. Moment is a vector quantity, meaning it has both magnitude and direction. But work is a scalar quantity. Okay. Now, when we talk about work, work is always quantitative. If I ask Eliana to do the work, as in do a particular work, as in sweeping the lab for me, when I come, all that I care about the quantity of work Eliana has done, whether she's been able to complete the sweeping of the lab. I will never be interested in where Eliana started. Where did she pass? Which corners did she pass to finish? No. All that I want is that, has she finished? I don't care about the direction. If I ask you to weed and I come, I will not care about where you pass to weed and which she started from which corner. And no. The magnitude of what you have done, has she been able to finish the work assigned to her? So whenever we talk about work, it's a quantitative thing, magnitude. Okay, that's why work is a scalar quantity. But for moment, it's a vector quantity. Please, are you okay?
Yes, please.
Okay, Sanam, help me. If moment is equal to force times perpendicular distance, what do you think will be the SI unit of moment? SI unit of moment. Sanam.
Sir, please, Newton meter.
So Newton meter or
Kilogram meter squared per second squared.
let's see. Newton is kilogram per meter squared. Kilogram meter per second squared times meter. So kilogram meter squared per second squared. And so you could easily determine the dimension of movement. Let's determine the dimension of movement. Okay, do it and tell me.
Mr. Adria,
Hello. Are you
please,
ready?
I can't see the board.
Who can see? Who?
Mr. Adria, Irene.
Irene, then, please, is it a general problem to all?
Yes.
No,
Yes, please.
Irene, then try rejoining. Let's see if that will sort out the problem. Okay. Yes, I've asked you to determine the dimension of moment. Dimension of movement. Are you ready with it? So just pick it from the derived a kilogram meter squared per second squared. Anita, go ahead. Give me the dimension. If the derived unit is this.
M times
Pardon?
M
M
L to the power 2.
L squared, the Cambrofo. L squared.
E to the power -2.
Good. So that is the dimension of moment. All right. So moment is basically the product, is the turning effect produced by a force around a fixed point. Around a fixed point. And this fixed point is what we term as pivot or fulcrum. Moment can be determined by the product of the force and the perpendicular distance, and it's a vector quantity. Its dimension or its unit is Newton per meter or kilogram meter squared per second squared, and this is the dimension. Now let's look at another special movement known as a couple system. Couple system. What is a couple? What is a couple? You see, whenever two, okay, let me use the bicycle. You know, in riding a bicycle, in riding a bicycle, you have the pedal at one end of it. You may drawing pedal, and then a pedal at the opposite end of it. So whoever rides will put the leg here. So, but you realize that at every instant, though there's a force which are acting oppositely to one another. So F1 and then F2 exerted on the pedal by the legs. This is the pivot or the fixed point around which the turning takes place. Okay, now when we ride a bicycle, these two forces, F1 and F2, are always of the same magnitude, but their directions are always opposite. Whilst one is acting downwards, the other one is acting upwardly. Then the line, the forces act along a common line. This is the common line around which the forces act. Okay, so you realize that these two forces have the same magnitude. They are oppositely in direction, but they act along a common line at a different point. Around a common line at different points. This F1 act here, this F2 also act here. They don't act at the same point, but they all act around a common line, and this is the common line. Such situation creates what we call a couple. Okay, so a couple system is formed whenever two forces of the same magnitude but opposite in direction act along a common line at different points. Let me put that into drawing or words. A couple system. Irene, are you back? Irene. Still mine. Whenever two equal but opposite forces act along a common line at different points. So that's what we mean by a couple. A couple system is created whenever two equal but opposite forces act along a common line at different points. So a typical example of a couple system is whenever somebody is riding a bicycle. Please, can you give me another example of a couple, a system we can term as a couple? Another example of a couple. Yes, Anita, Irene, Sanam, Ajua, Eliana. Another example of a couple system.
Mr. Idia, please, what if written on the board there, a couple system is created? It's blurry, so can you read it for me?
A couple system is created whenever two equal but opposite forces. Whenever two equal but opposite forces act along a common line, There is a common line. So these are the forces. F2 is acting upwardly. F1 is acting downward. So this is F2, F1. So whenever two but opposite forces act along a common line at different points. So there's a common line, but they all act at different points along the line. So riding a bicycle create a couple system. Give me other examples. Yes, Anita. Anita. Adwa. Roll call. Oh, an example of a couple system. Eliana, Divina, Sally. People are around, but they are quiet. Okay, Sanam.
Sir, please, would a seesaw be an example?
Yes, the seesaw creates a couple system. So this is the pivot. Sanam is here, Eliana is here. Okay. With the seesaw, usually the seesaw will not, because if this is Sanam is here, your weight acts in this direction. Eliana's weight acts in the downward direction. But with a couple, they should be opposites. Sanam, do you see it? Hello, do you see it? Okay.
Sir, please, not exactly.
But can you see the drawing indicated on the board?
Yes, please.
What I'm saying is that with the seesaw, This is how a seesaw, like it's just a bar put on a pivot. So supposing you are here, Senam is here, and Eliana is sitting at the other end. Your weight, which is the force, acts in the same direction. Okay. Your weight
Yes, please.
would act in the same direction. Eliana, your hand is up.
Yeah, please. The biceps and triceps, the elbow joint.
Okay, yes, it's in the books, but you see, you cannot see, so you cannot explain the couple system in that bicep, tricep. Okay, you can't see, but it is in the book that it creates a couple system. Do you understand what I'm saying?
Yes, please.
Yes. Any more view?
Turning a steering wheel.
Exactly. Turning a steering wheel.
And turning a key in a lock.
Turning a key in a lock. I'm coming. I'll demonstrate it. So look at turning the steering wheel of a car. Whenever we are driving, you hold the steer with your two hands, whilst one force goes down, another goes up. To say, yeah, unless I want to turn, then everything would, but okay, if I want to go straight, okay, this is how we do it. Then turning a key in a lock. When you are turning a key, the key is like this, okay? You push it up, this force would also push it down. So it's like, whilst you have a force pushing this up, there's another one. Okay, this is going upward, this is going downwards. So it creates that turning effect. Is that okay? So the bicycle pedaling a bicycle, then steering wheel, then the key knob, okay, all are examples of a couple system. Do you have any more to share with us? All right. So whenever you have this situation where two equal but opposite directed forces acting along a common line but at different points, okay, they create a turning effect. Sanam, your hand is up.
Yes, please. I was wondering if a pulley will also be an example.
A pulley.
Yes, please.
With a pulley, the forces will not be equal. Because what we use a pulley system for, we use it to lift loads. So a pulley system is like this. This is one force or weight or load, which I want to carry. Then a force F1 is applied at one end of the pulley. Okay, so look at the weights. The weight of the load, mg. The force to pull this would also take in the other in this direction. Sanam, do you see it?
Yes, please.
So it's obvious the pulley system will not. The weight, which is the force, acts in one direction. If you want to lift it, you pull it in the other direction. All right. So with a couple system, we are always looking at two forces and even this. You see, the forces will not even be equal because of this. Anita, are you there? The forces will not be equal because for me to carry this, F1 To lift it up, F1 must be greater than mg. Sanam, do you see it?
Yes, sir.
Oh. All right. The turning effect of a couple. The turning effect of a couple is what we call as torque. The turning effect of a couple is the torque. The turning effect produced by a couple system is the torque. The word torque is used for both turning effect of a couple and then even movement, the turning effect of a force. So we use the two words for the same thing. Okay, the turning effect, the moment of a force, which is also the turning effect produced by a force, and then the turning.
Please, I can't see what's in the bracket.
It's a symbol. It's a Greek symbol. I read Mikrampo Mihunu, Papa, but that's a symbol. Okay. It looks like a T, but not T. We design it. Amania Yenya. What's you trying to say? That's a symbol for a torque. So the turning effect of a couple is the torque. All right. Now, if I have a couple, F1, F2. There's the center. The length of the common line is L. And I want to calculate for the torque. I want to calculate for the torque. Then the torque, the name for this is tau. Tau. The letter is pronounced as tau. T-A-U. Okay, it's a Greek letter. If I want to calculate the turning effect of the couple, then turning effect, moment is force times perpendicular distance. So it means that I have to calculate the perpendicular distance, either F1 or F2 mixed with a pivot, which is the axis around which the turning takes place. Okay. And since the distance is L,